This lecture will cover solution reactions. So aqueous solutions are homogeneous mixtures of a substance within water. So for example, saline or NaCl solution. A sodium chloride solution contains independent sodium and chloride ions dissolved in water. When silver chloride is added to water, though, it remains as a solid. It doesn't dissolve into independent ions because it is insoluble in water. Strong electrolytes are substances that completely dissociate into ions in water, like sodium chloride. When substances containing polyatomic ions dissolve, the polyatomic ions stay together as one unit. For example, silver nitrate. Silver nitrate solution contains independent Ag plus and NO3 minus ions. Strong electrolytes conduct electricity. So a compound is soluble in a particular solvent if it dissolves in that solvent, so sodium chloride or silver nitrate. A compound is insoluble in a particular solvent if it does not dissolve in that solvent, like we saw here with silver chloride. Silver chloride is insoluble. So here are solubility rules. It's just a table that tells you what's generally soluble and what's generally insoluble in water. So for example, up top, these are ions that are mostly soluble. So for example, these are compounds containing the following ions are mostly soluble. So any compound with lithium, sodium, potassium, or ammonium ions is soluble. There are no exceptions. Any compounds with the nitrate ion or the acetate ion are soluble. No exceptions. Most compounds containing chloride, bromide, and iodide ions are soluble, but there are exceptions. So when silver, mercury, or lead-2 are in a compound with chloride, bromide, or iodide ions, these are insoluble. Anything else, though, is soluble. And then sulfate ions are generally soluble, or compounds with sulfate ions are generally soluble, but when it's paired with calcium, strontium, barium, or lead-2, they're insoluble. Then down here, these are mostly insoluble, so most hydroxides and sulfides are insoluble. The exceptions are when any of these are paired with lithium, potassium, sodium, or ammonium. Those are all soluble. And the other exception is when sulfide ions pair with calcium, strontium, or barium. Those are soluble. When hydroxide ions pair with calcium, strontium, and bromine, the compounds are slightly soluble. So we can generally consider those insoluble. And then compounds containing carbonate ions and phosphate ions are generally insoluble. The exceptions are when they pair with lithium, sodium, potassium, and ammonium. They are soluble. So you don't need to memorize this. You'll be given this chart for quizzes and tests, but you do need to know how to read this. So I suggest you practice reading this and understanding what this chart is saying. So precipitation reactions are reactions that form a precipitate, which is a solid, when two aqueous solutions are mixed. So here we have potassium iodide solution and lead nitrate solution. These are both aqueous solutions. Both of these compounds are soluble. When you mix them, though, you make solid lead iodide and aqueous potassium nitrate. And you can see here, this yellow mass it's forming, that's solid lead iodide. So this is a precipitation reaction. The lead iodide is the precipitate. So then you can also mix two things like potassium iodide and sodium chloride and have no reaction occur. That's because because potassium iodide and sodium chloride are soluble, and potassium chloride and sodium iodide, which is what they would make, are also soluble. So no reaction happens when you mix these. And then what you'll do is you'll use the solubility chart to predict the reactions, the precipitation reactions, predict what will happen. Will it precipitate form or not? And if so, what is that precipitate? So the key is that only insoluble compounds form precipitates. So if we have potassium iodide and lead to nitrate, we swap partners, and that gives us our potentially insoluble products. So potassium, nitrate, and lead iodide. And then you'll look at your solubility chart and you'll see potassium nitrate is soluble, lead iodide is not soluble, so lead iodide is the precipitate that will form. So write the chemical equation for the precipitation reaction that occurs, if any, when you mix sodium carbonate and copper 2 chloride. So we swap partners and write down what our potentially insoluble products are, which are sodium chloride and copper 2 carbonate. And then we use our solubility chart to determine if any of these are going to be soluble or insoluble. Well, sodium chloride is soluble, but copper 2 carbonate is insoluble. So that will be the precipitate that forms, and we can write the reaction down below. So I would suggest practicing these. Your book has lots of problems, and I put a practice worksheet up on D2L. It's just really getting used to reading the solubility chart. You always do the same thing though. You swap partners, look at the solubility chart, determine if anything insoluble will form, and if so, you have a reaction that occurs. If not, no reaction occurs. So let's look at how to write these chemical equations. So there's 3 different types of chemical equations we'll use when we're looking at solubility or precipitation reactions. The first is the molecular equation. So like we saw in the previous slide, we have sodium carbonate and copper 2 chloride reacting to form sodium chloride and copper 2 carbonate, solid copper 2 carbonate. The complete ionic equation is when we write out all of the ions individually. So anything that's aqueous, remember, they'll form ions in solution. Solids will not. So we break everything apart. So our complete ionic equation for the above reaction is 2 sodium ions plus 1 carbonate ion plus 1 copper 2 ion plus 2 chloride ions. And again, that's because both of these are aqueous. So they break apart into sodium and carbonate and copper and chloride ions in solution. So we have those yielding 2 sodium ions, 2 chloride ions, and copper 2 carbonate. So again, that's because sodium chloride is aqueous, so it will dissolve into its ions in solution. But copper 2 carbonate is a solid, so it does not form ions in solution. It stays the solid. And then what we do is we look for what are called spectator ions. And spectator ions are ions that do not react or participate in the reaction at all. And those are the things that show up on both the reactants and the product side. So for example, sodium is a spectator ion because it does not participate in the reaction at all. It shows up on both the reactants and product side, so we can cancel that out. The other spectator ion are the chloride ions for the same reason. So our net ionic equation then is writing our complete ionic equation without the spectator ions. So in this example, we get carbonate ions react with copper 2 ions to form copper 2 carbonate. So again, I suggest you practice doing lots of these problems as well. And like I said, there's a practice worksheet on D2L, and there's lots of problems in your book. So what I suggest doing is when you are practicing this, predicting products, you not only write out the molecular equation, but you do what we did here, right? The molecular equation, write the complete ionic equation, and write the net ionic equation.